Hi guys, this is a new video in the series on differentiation under math studies. This is the second video that shall act as a general review of the concepts that we have discussed, and I shall tackle the three questions that are on the screen in front of you, and I shall begin with question 1 shortly. So the first question that we shall tackle came in paper 1, May 2008, time zone 2, question 15. Kindly take a minute to attempt to solve the question, and the answer shall follow through shortly. So the first question requires us to write down the equation of the tangent to the graph of f of x at P, where P is the point 4, 2 and the gradient is 0. So in order to write the equation of a tangent, we need the slope and a point. We are given both, so the point is 4, 2 and the slope is 0. So all we have to do is just substitute into the formula y minus 2 equals 0 times x minus 4. Hence y minus 2 is just 0 and y equals 2. So for question B, we are required to state whether f of 4 is greater or equal or less than f of 2. So this depends on whether the function is increasing or decreasing. So we need to determine the trend of the function between the values of x equals 2 and x equals 4. If the function is increasing, then f of 4 shall be greater than f of 2. If the function is decreasing, then f of 4 shall be less than f of 2. So we are told that for 1 less than x less than 4, f dash of x is less than 0. If f dash of x is negative, then we know that f shall be decreasing. And if we know that f is decreasing, then we know that the value of y when x equals 2 shall be greater than the value of y when x equals 4. Hence, f of 2 is greater than f of 4. Or in other words, f of 4 is less than f of 2, because as x increases, as x goes from 2 to 4, the value of y or the value of f of x decreases. It's a decreasing function. And we know this because we are told that the derivative is negative within this domain. So moving on to question C, we are told that f of x is increasing for 4 less than x less than 7. So basically, given these two pieces of information, we know that point P is a point that lies between two different trends of the function. Before point P, we know that the function is decreasing. Now, after point P, we are told that the function is increasing. So we want to know what type of a point P is. What can we say about point P? So if you take a look at this random graph, you can tell that when the function goes from increasing to decreasing, then the point at which the change occurs is a local maximum. However, if the function was initially decreasing, as in here, and then it switched into an increasing function, as in there, then the point at which this change occurs is a local minimum. So basically, you can visualize this in your head by drawing an imaginary curve in your head. If the function is upsloping, if it's going upwards, and then suddenly it decided to go downwards, this looks like a maximum point. This looks like a frown. We mentioned this in previous videos. However, if the function was decreasing, so downsloping, going downwards, and then suddenly it began to increase. So if you visualize this in your head, you will visualize a minimum point. So this is a smiling face with a point at the very bottom of the curve. So in this case, since the function goes from decreasing to increasing, then this second part applies, and we can tell that P is a minimum point. So take a minute to copy this down if you will. I shall move to question 2 shortly. So the second question that we shall tackle in this video came in paper 1, May 2014, time zone 2, question 13. Kindly take a minute, attempt to solve, and the answer shall follow through shortly. So in question A, we are asked to label the local maximum as A on the graph. So where is the local maximum on this graph? Obviously, it's right there at the point where the function goes from increasing to decreasing. In question B, we are asked to label the local minimum on the graph. So we shall choose this point right there. This is the local minimum. In question D, I'm going to skip question C for a second. In question D, we are asked to draw the tangent to the curve at x equals 1. So in order to do that, I shall draw a line that barely touches the curve right there at a point where roughly x equals 1. So this is my tangent. So take a minute to look at the marking scheme version of the answer for reference. So as we said, the maximum point, which we shall label A, shall be right there. The minimum point, which we shall label B, shall be right there. And we shall draw a tangent that touches the curve at one point only, corresponding to x equals 1. So let's go back to check question C out. Question C requires us to write down the interval where f dash of x is less than 0. So when is f dash of x less than 0? When the function is decreasing. So when is the function decreasing in this graph in front of you? Obviously in the region that extends from this point up to this point. The region in between these 2 points is the only region where the function is decreasing. Otherwise, in this region and in this region, the function is increasing or upsloping. So we want to determine the region where the function is decreasing, or actually the x-coordinates of the turning points, since we know that our required region lies between the 2 turning points, between the maximum and the minimum. So if we can find the x values of the maximum and the minimum, we can easily find the domain in which the function is decreasing. So let's attempt to do that. So the first thing that I shall do is access the y equals button to get this screen, and then write down the equation of the curve, as you can see right there, x cubed plus 2x squared minus 5, corresponding to this equation. Then I shall click on trace and get a picture that matches the picture that is given to me in the exam. Now I want the x-coordinates of the local maximum and the local minimum of the graph, and there is a function in the calculator that can help you do that. So second trace maximum, you want to determine the left bound, so any point to the left of your maximum, then a right bound, so any point to the right of your maximum, and then you guess where the maximum roughly is, and the calculator tells you that the maximum point is at x equals negative 1.3333 and so on, or just negative 1 and 1/3, or negative 4/3. These are all different ways of saying the same thing. So we shall repeat the process for the minimum point. Second, trace minimum point, determine the left bound, so somewhere to the left of my minimum, then somewhere to the right of my minimum, and then a guess as to where the minimum is. And I am told that the minimum is at x equals negative 1.776 e to the power of negative 6. So this is interesting. So just for your information, this is a very small number, and sometimes the calculator does that. So negative 1.776 times 10 to the power of negative 6, which is basically 0.00000001776. So this is the calculator's way of telling you that the answer is 0. Sometimes, due to a tiny miscalculation on the calculator's part, it's just a machine thing, it has nothing to do with you. Whenever you see an abnormally small number like that, you can tell automatically that the calculator intends for you to understand that x here is equal to 0. And you can tell from the graph that x is roughly 0. So this is where the minimum point is. Hence, the interval where the function is decreasing, which lies between this point and that, is actually negative 4/3 less than x less than 0. So moving on to question E, we are asked to write down the equation of the tangent at x equals 1. So we need a point and a slope in order to do that. We want the equation of this tangent which we drew. So the slope is obtained by evaluating f dash of x at the point where x equals 1. So I got f dash of x in the previous question. I solved in a different way, and I differentiated this black function right there and got the derivative function. So this is very simple differentiation. If you had solved question C like I have done using the calculator only, then in question E you will need to perform this step of differentiating the function. So the derivative of x cubed plus 2x squared minus 5 is 3x squared plus 4x. So in order to get the slope, I shall evaluate this green function when x equals 1. And this gives me a 7. Now, to get a point, I need to find the value of y when x equals 1. So I shall just substitute 1 into the original function f of x. So I shall substitute 1 into the black function right there. So 1 plus 2 minus 5 gives you negative 2. Again, to get the slope, I substituted 1 in the green function to give me m. To get the y value when x equals 1, I substituted 1 in the black function to give me y when x equals 1. So I got the point which is 1 comma negative 2, and I have a slope. I just use the point slope formula, and the equation is y plus 2 equals 7 times x minus 1. So take a minute to copy this down if you will, and I shall begin question 3 shortly. So question 3 came in paper 1, May 2010, time zone 2, question 15. Kindly take a minute and pause the video, attempt to solve, and the answer shall follow through shortly. So in question A, you are asked to state whether f of 0 is greater than, less than, or equal to f of negative 2. And like we said before, this depends on whether the function is increasing or decreasing in this region. So from negative 2 to 0, how is the function acting? From negative 2 to 0, the function is increasing. So since the slope is positive in the required region, which is from negative 2 to x to 1, this is the region that contains the negative 2 and the 0. Since f dash is greater than 0, then the slope is positive, which tells us that the function is increasing. Hence, f of 0 shall be greater than f of negative 2. So there is your answer to question A. So moving on to question B, we are told that the point P with coordinates negative 2 and 3 lies on the graph of f of x. And we are asked to write down the equation of the tangent to the graph of f of x at the point P. And as we said before, in order to write the equation of a tangent, we need a point and a slope. So the point is already given. I just need to find the slope when x equals negative 2, because this is the x value of point P. So when x equals negative 2, I am told that f dash of x equals 0. Hence the slope is 0 when x equals negative 2. So let's take a look at the answer. So we have point P with coordinates negative 2 and 3, and we have determined that the slope is 0 at this point. Hence we just plug the values into the formula, the point slope formula, getting y minus 3 equals 0 times x minus negative 2, which is just y minus 3 equals 0, because 0 times anything is 0. Hence, the equation is y equals 3. So let's move on to question C. Question C tells us, from the information given about f dash of x, state whether the point negative 2, 3 is a maximum, a minimum, or neither. So we said before that we can visualize the graph in our head. If the function goes from increasing to decreasing, then it was going up and then suddenly it changed and now it is going downwards. So this is a maximum point. However, if the function was initially decreasing, downsloping, and then suddenly it changed, it turned into an increasing function, an upsloping function, then the point at which the change occurred is a minimum point. So we need to know how the function was behaving before and after the turning point. How do we know that the point negative 2, 3 is a turning point? Because the slope is 0 at negative 2. Hence this is a turning point. Before negative 2, the slope was less than 0. It was negative. After negative 2, the slope became positive. So I was decreasing, and now after the turning point, I'm increasing. So obviously, this is a minimum point. So take another look at the answer. Like we said, f dash of x was less than 0 before our required value, greater than 0 after our required value. Hence, the function is decreasing before and increasing after the required value, and this describes the state of a minimum point. I'm downsloping before and upsloping after, or decreasing before and increasing after. So take a minute to copy this down if you will, and I have concluded this video. I hope you have found it useful. Thank you.